Hello friends, in this video I'd like to solve the following problem from the International Mathematical Olympiad 1970, long-listed problem number 16, proposed by Bulgaria. We wish to show that the following equation, square root of 2 minus x squared plus cube root of 3 minus x cubed equals 0. This equation has no real solutions. It's a very simple problem, here are my hints. Notice that the first expression must make sense, so 2 minus x squared must be greater than or equal 0, so x squared must be less than or equal 2. And also, notice that square root is also always non-negative, so the cube root of 3 minus x cubed must be a non-positive number. And try to get some kind of contradiction from there. So give this problem a try, and I will see you in just a minute. Alright, so first, notice that we must assume, definitely, that 2 minus x squared is greater than or equal 0, so x squared is less than or equal 2, which happens when x is between square root of 2 and minus square root of 2. Alright, but also, this is non-negative, so if this is the case, notice that we can write cube root, this expression is minus square root of 2 minus x squared, which is non-positive. Which means, after taking a cube on both sides, 3 minus x cubed must be also less than or equal 0. So x cubed must be greater than or equal 3. So x must be greater than or equal cube root of 3. But let's consider these two conditions, this right here and this right here. Well, they are not possible at the same time, because notice that cubic root of 3 is definitely greater than square root of 2. Well, why is that, you may ask? Because this is equivalent to saying that cube root of 3 to the 6th power is greater than square root of 2 to the 6th power. This is equivalent to saying that 3 squared is greater than 2 cubed. This is equivalent to saying that 9 is greater than 8, which is of course true. So, if I denote this condition by asterisk and this condition by a double asterisk, they cannot be true at the same time. Cannot be true. Cannot be satisfied at the same time. Which means that our equation has no real solutions. And that closes our problem. Rather easy. So thank you very much for watching. I will see you next time. Goodbye.